Period 1 element. A period 1 element is one of the chemical elements in the first row of the periodic table of the chemical elements. The periodic table is laid out in rows to illustrate periodic trends in the chemical behavior of the elements as their atomic number increases. A new row is begun when chemical behavior begins to repeat, meaning that elements with similar behavior fall into the same vertical columns. The first period contains fewer elements than any other row in the table, with only two, hydrogen and helium. This situation can be explained by modern theories of atomic structure. In a quantum mechanical description of atomic structure, this period corresponds to the filling of the 1s orbital. Period 1 elements obey the duet rule in that they need 2 electrons to complete their valence shell. The maximum number of electrons that these elements can accommodate is 2, both in the 1s orbital. Therefore, period 1 can have only 2 elements. All other periods in the period table contain at least 8 elements, and it is often helpful to consider periodic trends across the period. However, period 1 contains only 2 elements, so this concept does not apply here. In terms of vertical trends down groups, helium can be seen as a typical noble gas at the head of group 18, but as discussed below, hydrogen's chemistry is unique and it is not easily assigned to any group. Although both hydrogen and helium are in the s block, neither of them behaves similarly to other s block elements. Their behavior is so different from the other s block elements that there is considerable disagreement over where these two elements should be placed in the periodic table. Hydrogen is sometimes placed above lithium, above carbon, above fluorine, above both lithium and fluorine, or left floating above the other elements and not assigned to any group in the periodic table. Helium is almost always placed above neon in the periodic table as a noble gas, although it is occasionally placed above beryllium due to their similar electron configuration. Hydrogen is the chemical element with atomic number 1. At standard temperature and pressure, hydrogen is a colorless, odorless, nonmetallic, tasteless, highly flammable diatomic gas with the molecular formula H2. With an atomic mass of 1.00794 amu, hydrogen is the lightest element. Hydrogen is the most abundant of the chemical elements, constituting roughly 75% of the universe's elemental mass. Stars in the main sequence are mainly composed of hydrogen in its plasma state. Elemental hydrogen is relatively rare on Earth, and is industrially produced from hydrocarbons such as methane, after which most elemental hydrogen is used captively, with the largest markets almost equally divided between fossil fuel upgrading, such as hydrocracking, and ammonia production, mostly for the fertilizer market. Hydrogen may be produced from water using the process of electrolysis, but this process is significantly more expensive commercially than hydrogen production from natural gas. The most common naturally occurring isotope of hydrogen, known as protium, has a single proton and no neutrons. In ionic compounds, it can take on either a positive charge, becoming a cation composed of a bare proton, or a negative charge, becoming an anion known as a hydride. Hydrogen can form compounds with most elements and is present in water and most organic compounds. It plays a particularly important role in acid-base chemistry, in which many reactions involve the exchange of protons between soluble molecules. As the only neutral atom for which the Schrödinger equation can be solved analytically, study of the energetics and spectrum of the hydrogen atom has played a key role in the development of quantum mechanics. The interactions of hydrogen with various metals are very important in metallurgy, as many metals can suffer hydrogen embrittlement, and in developing safe ways to store it for use as a fuel. Hydrogen is highly soluble in many compounds composed of rare earth metals and transition metals and can be dissolved in both crystalline and amorphous metals. Hydrogen solubility in metals is influenced by local distortions or impurities in the metal crystal lattice. Helium is a colorless, odorless, tasteless, non-toxic, inert monatomic chemical element that heads the noble gas series in the periodic table and whose atomic number is 2. Its boiling and melting points are the lowest among the elements and it exists only as a gas except in extreme conditions. Helium was discovered in 1868 by French astronomer Pierre Janssen, who first detected the substance as an unknown yellow spectral line signature in light from a solar eclipse. In 1903, large reserves of helium were found in the natural gas fields of the United States, which is by far the largest supplier of the gas. The substance is used in cryogenics, in deep-sea breathing systems, to cool superconducting magnets, in helium dating, for inflating balloons, for providing lift in airships, and as a protective gas for industrial uses such as arc welding and growing silicon wafers. Inhaling a small volume of the gas temporarily changes the timbre and quality of the human voice. The behavior of liquid helium-4s2 fluid phases, helium-I and helium-2, is important to researchers studying quantum mechanics and the phenomenon of superfluidity in particular, and to those looking at the effects that temperatures near absolute zero have on matter, such as with superconductivity. Helium is the second lightest element and is the second most abundant in the observable universe. Most helium was formed during the Big Bang, but new helium is being created as a result of the nuclear fusion of hydrogen in stars. On Earth, helium is relatively rare and is created by the natural decay of some radioactive elements because the alpha particles that are emitted consist of helium nuclei. This radiogenic helium is trapped with natural gas in concentrations of up to 7% by volume, from which it is extracted commercially by a low-temperature separation process called fractional distillation.